In today's video, I'm going to be showing you my networking library called Packet. Packet is used to replace remote events and remote functions and will help with reducing network data that is sent between the server and the clients. To get started, all you need to do is under Models inside of the toolbox, search for Packet, and you'll find a model created by 5UPHI, which is called Packet. Once we click on this module, it will be added to our workspace. And what I'm going to do now is move this module into replicated storage, and I'm also going to rename it to be called Packet. What I'm going to do now is create a script inside of server-script service, and I'm going to name the script server and give it a run context or server. I'm going to then duplicate the script and place it into replicated storage and rename it to client and set the run context to client. And then I'm going to place these scripts side by side. The first thing I'm going to do is set these scripts to strict mode. This is not mandatory, but I personally like to set it to strict, and just to show that the module works correctly in strict mode. And I'm going to do this both for the server and the client. And then I'm going to require the packet module. So I'm going to say local packet equals require game dot replicate storage packet. And I'm going to do the same on the client side as well. And now let's use the packet module to create our packet. So I'm going to say local my packet equals, and all you do is call the packet like a function, and we must pass in a name for this packet. So I'm just going to name it my test packet, and then we do the same on the client side like so. And now on the server side, in order to detect when this packet is fired, all I need to do is say my packet dot on server event connect function, and this function is going to give us the player. So let's say player, and I'm going to print the player's name. And then on the client side, all I'm going to do is fire the packet. And if we now play the game, we should see that the player name gets printed on the server side. And it's also possible to do it the other way around. So what I can do is fire the packet on the server side, but let's add a little task wait, so to give some time for the client to enter the game. And let's use this over here, but instead of using on server event, we must use on client event. We also get a problem now because there is no player being received for the on client event. So if we remove this and we remove this, and let's just print test, and if I now press play, we should see that the client now prints test. Now the fire function will fire to all clients on the server, but if we only want to fire to a specific client, what we can do is let's first get the player object. And once we have the player object, we can use the fire client function and pass in the player that we want to fire to only fire an event to one client. Now, if I want to send a value from the server to the client, I can't just add it into the fire directly. I must first predefine which types I want to send along with this packet. So over here, I'm going to type packet and press dot, and here we should see a very long list of many types of data we can send along inside of the packet. Now we could just send the any type, and this will allow us to send any type through the fire event. So if I go over here, press comma, we can see that any shows up over here. But if I change this to a number type, now we should see over here, it should say number. So just for now, I'm going to use the any type, and it's going to allow us to send any value we want. So I'm just going to send the value of 123. And then over here, I'm going to say number, and I'm going to print this number over here. Now we can see that we get a problem, and that's because we've defined the any type on the server side, but we haven't defined it on the client side. So we need to make sure you add this same type on both the server and client side, like so. And if we now play the game, we should see that it prints 123. So the benefit of the any type is that it will dynamically be able to detect how to send this value that we pass into here. But the downside is that the any type will add an extra byte onto our data. So if we can define the number type, then we will reduce the amount of data sent by 1 byte. So if we type in number, we should see many number types, and you might not know what each one of these types mean. So the best way to check is if you come into the packets module, and over here we have types. If I open this types module, and here we can see that S8 means signed, and it has 8 bits of data, and it has a number range between -128 up to 127. And S16 has a number range between -32,768 and goes up to this value. And if we use U8, which means unsigned, and 8 bits, it goes from 0 up to 255. So here we can see a good table, so we know which type we should select. So here we have a number that is 123. We can see that this fits inside of this range, and it also fits inside of this range, but I don't really care about negative numbers, so I'm going to use the U8 type. So I'm going to say number U8, and now we need to make sure we do the same on the client side. So I'm going to change the client to also be U8 and press play. And we can see that we still send the same value, but now we've reduced the amount of data we use because we're no longer using any. But we need to be careful because if we remember, our max value is 255. So if I sent a value of 265 and press play, we should see that the value wraps round back to 0, 1, 2, 3, and wraps all the way down to 9. So if we go past this value, it wraps round back to 0 and goes round and round and round. So if we wanted to support this value here, we would have no choice but to go from 8 bits up to 16 bits. So let's change this to 16 bits and also do the same on the client side and press play. And we should see that now we can send this value with 16 bits. And if we want to send more than just a number, we can add more types to our packet. So to do that, I can just say packet, and let's send a string type, and let's also send a Boolean 8-bit type. And I'm now going to copy this over to the client because we need to make sure it's the same on both the server and client. And now it's giving me errors because it's saying that we need to send a string and Boolean. So let's send a string and a Boolean of true. Let's also do the same over here, but let's just use ... and put ... in here, and that should get all the values. And if we now run the game, we should see it sends. If you want to send a table, it's very simple. So let's replace this string and Boolean to a table type. And then inside of this table, I'm going to have a key called key1. And this is going to be a string type. And then I'm going to have another key called key2. And we can name these keys anything you like. I'm just calling them key1 and key2. And this is going to be a Boolean 8-bit type. Okay, so now over here, if we look, we can see that it's expecting a table with key1 and key2 with a string type and Boolean type. So I'm going to delete these two values over here, send a table, and I'm going to have key1 equals ABC, key2 equals true. Now we need to make sure that we define the packet the same on both the client as well. So I'm going to copy and paste this over here. And if I now play the game, we should see that the table gets replicated correctly over to the client. And another thing to take note is the key and table have zero effect on the amount of data that's being sent over the network. So even if you have a very long key name, this will have zero effect on the amount of data that the packet needs to send to the client. So don't worry about how long your keys are because it doesn't have any effect. Now, if you want to send an array of items instead of a dictionary of items, what we can do is pass in another table, but instead of defining a key, we just simply pass in the type that this array will store. So I'm going to say packet, and let's make this a number array, and I'm going to set to U8. So now, if we look over here, we can see that it's expecting a number array. So let's add some numbers into an array. It's going to send 3, 7, 4, 1. And if we now copy and paste this to the client, because we need to make sure the client has the same packet defined, and press play, we can see that the array gets sent over to the client. And our tables can be as complex as we like. For instance, instead of having this array separate over here, I could move this array to be inside of the dictionary. So for instance, I could have key3 equals, and let's move this array into the dictionary, like so. And now I need to move it also over here. So I'm going to say key3 equals, and move this over here. And this will work fine. And if I wanted to, I could even make this dictionary be part of an array. So if I wrap this in brackets, now this is an array with dictionaries inside. So let's change this to be an array of dictionaries, like so. And let's just send 3 dictionaries in our array. And let's just call this one A, B, C, and let's just set this one to false, and let's set this to a number of 2, and we need to make sure that the client has the same packet defined. So let's copy and paste this over here and press play, and we should see that now we send an array of dictionaries with key 1, 2, 3, and key 3 has an array of numbers within them. So your tables can get as complex as you want them to be. Let me now show you how we can use a packet like a remote function. So let's first just simplify the packet so we don't have so many types. Let's just send a number and remove all this, like so. Okay, so now what we need to do is define what type the client is going to respond back to us with. So to do this, all we do is say my packet, and we're going to call the response function. Now, if they're not going to respond with anything, we can just leave it empty. But if we want to say what they're going to respond with, we can just pass in the type that they're going to respond with. Let's say that they're going to respond with a string. So we're going to send them a number, and they're going to send a string back to us. Now, when we want to get a response, we must always use fire client. We cannot use fire because all clients can't respond to a single fire event. So we have to use fire client. And we also should see that this returns a string now. If we change this to a number and check, we can see it returns a number now. But if we say string, then it should accept a string type to come back. So I'm going to say local response equals, and I'm just going to print this response, like so. And now we're going to need to match the packet over here, like so. And we also need to add the response, But there is a different way we can call this response function. Instead of calling it like this, we can call it in a single line over here like this. This will have the same effect. You can either do it in two separate lines or you can have it in a single line like so. And we need to make sure that the client also defines the response. And now, instead of using onClientEvent, we must use myPacket.onClientInvoke. And instead of connecting to it, we must say equals function like so. And here we can see we've got a problem, and it's saying it wants to return a string type. So that's why it's given us a error. So I'm going to say return. If I return a Boolean, we can see it gives us a problem. But if we return a string called test, the error goes away. We can get rid of this now because we no longer need this. And over here, we should receive this number that the server sends to us. So let's say number and print the number like so. Okay, so we're going to send the number of 26. The client's going to print that number. Then it's going to return the string test. The server is going to receive that string and print the string over here. So let's now play the game. And we can see client print 26 and then the server printed test. Now, if you've watched my remote function video from before, you'll be aware that remote functions have a problem where if an exploiter does not respond a message back to the server will yield over here forever and will cause a memory leak. But Packet doesn't have this problem. Packet has a built-in timeout feature. So by default, the packet needs to be sent back to the server within 10 seconds. But we can change this value. So over here, I can say myPacket.response timeout, and I can set this to any value I like. The default value is 10, but just for now, I'm going to set it to 3, so it times out a lot quicker. And then over here, instead of returning instantly, I'm going to add a task wait. And I'm going to wait for 5 seconds. So now if I play the game, we can see that the client got the message of 26. Then the server timed out and printed nil. And then after 5 seconds, the client tried to respond with test, but then the server gave an error saying response thread not found for packet my test packet, discarded response test. So it disregarded this test value because it timed out before the client could send it back. It's also possible to change the default value that is responded with if the client times out. So we can see by default it will return the value of nil, but over here I can say myPacket.response timeout value equals, and for instance I might just want it to return a empty string. So now instead of printing nil, it should print a empty string. Here we can see it printed a empty string instead of nil, and we get the same warning as before. And if you wanted to use a remote function but in the opposite direction, the only difference is the server would use myPacket.onServerInvoke and the client would use myPacketFire to send a message to the server. Another thing to take note of is if you call packet with the same name multiple times, it won't create new packets. It will just return the previous created packet. So that means if we had another script, so if I duplicate this script and have two server scripts, this packet over here and this packet over here are going to be the exact same packet object. But the problem with this is we now have to define the exact same types in 3 scripts. Once in this script, once in the client side script, and over here as well. And you may not like having to do this. You may only want to define a packet once and have all scripts use that singly defined packet. So let me now show you how we can define a packet in a single location and have the server and client use the module to get the packets. So let's first delete this duplicated server script. And inside of replicated storage, I'm going to create a new module script, and I'm going to name this script packets. And then this is just personal preference, but I'm going to put the packet script inside of the packets script. And inside of this packet script, what I'm going to do is I'm first going to make the script strict. Then I'm going to require the packet script, but we just have to say script.packet to get the packet script, which we placed inside. And then I'm going to return a table. So now in this table, we're going to define all the packets that our project is going to use. So just like we did over here, I'm going to say my test packet. Now I'm going to call this my test packet 1, and I'm going to copy and paste this part of the packet over here equals my test packet 1. And then let's say we wanted another packet in our project. So I'm going to say, copy and paste this down here. I'm going to call this my test packet 2, give it a unique name. And let's say this packet, we need to send a string type. And there we have it. We have finished our packets module. So all we need to do now is change our scripts on our server and client side to use this packets module instead. So over here, instead of packet, I'm going to change this to packets. So we require this module instead. We don't need to define the packet anymore because we're doing that inside of the module. And what I can do over here, we're no longer going to receive a response because this is not a remote function. These are remote events. I'm going to say packets dot, and we can see we get the 2 packets that we defined within the module. I'm going to use packet 1, which needs to be a number. And I'm going to say fire to send to all clients. And over here, it just wants to have a number type without a player. So we can get rid of player over here. And we no longer have a response. And we want to do the same on the client side. So just like we did over here, we want to get the packets module. Then instead of connecting to the packet we created before, we can say packets dot, we can connect to packet 1 dot on client event connect function. And over here, we should receive this number. So over here, I'm going to say number, print number. And if we wanted to, we could also connect to my test packet 2. So over here, I'm going to say packets dot my test packet 2 on client event connect function. Now on this function should receive a string type, not a number type. So over here, I'm going to say str print str. Okay, and over here we can also just fire to the my test packet 2. So let's say packets dot my test packet 2 fire. We can see it wants a string. So let's send ABC. And if we now play the game, we should see that it prints 26 and ABC. So this is how we can define our packets in a single location and then just use the packets module to get our packets. Okay, so let's now go over some of the other types. But before we do that, let's simplify the project slightly. Let's get rid of my test packet 1 and 2 and just have one test packet, like so. And let's change this to a ... And let's get rid of this and call this my test packet. Okay, so if we now go into our packet module, we should see the types module. And in here we have a list of all the types that come by default with the module. Now most of these types are pretty straightforward, but some of them may be a bit more complex than others. And if we look inside of the types module, we can see there's a separate module for every type. Let's take a look at a simple one. For instance, if we look at number U8, we can see that this module only has a read function and a write function. When we write the value to the buffer, we allocate 1 byte of memory, and then we write the 1 byte into the buffer. And then on the other side, we just read the 1 byte from the buffer. If we look at U16, it's essentially the same, but instead of having 1 byte being allocated and written, it allocates 2 bytes and writes 2 bytes to the buffer. But if we look at U4, this one works slightly differently. Here we can see what happens is we allocate 1 byte, but we store 2 values in that 1 byte. And we use 4 bits for half of the byte and another 4 bits for the other half of the byte. So we're able to store 2 numbers within a single byte. So let's now use the U4 type and see how it works. So over here, inside of our packets, I'm going to change this to number U4. And now over here, we can see we get an error. If we mouse over, we can see it wants a table of numbers. So we want a table with 2 numbers within them that each number will consume 4 bits each. And because it's only 4 bits each, the max value, it goes from 0 up to a value of 15. If we go to 16, it will wrap back round to the value of 0. So for instance, I could send the value of 2 and the value of 8. And now if I play the game, we should see that the value of 2 and 8 get sent to the client, and this will only consume 1 byte of data. Let's also take a look at Boolean 8 and Boolean 1. So if we look at Boolean 8, all we're doing is we're assigning 1 byte, which is 8 bits, for the Boolean, and then if the value is equal to true, then we pass in the value of 1. If it's not, we pass in the value of 0. Then we read that 1 byte. If the value is 1, we return true. If it's not, we return false. But if we look at Boolean 1, we can see we also allocate 1 byte of data, but each bit stores 1 Boolean. So we can have a total of 8 Booleans within 1 byte, because each Boolean takes up 1 bit from the byte. So let's now use Boolean 1 to see how it works. So over here, I'm going to change this to Boolean 1. And if we look over here, we can see it wants an array of Booleans. So we can have 8 Booleans in total. So let's just give it some random Booleans. And I can just copy and paste this to make it 8. So here we have 8 Booleans. And if I play the game, we should see that all 8 Booleans get sent to the client, and it only consumes 1 byte of data to send all 8 of these Booleans. Each Boolean costs 1 bit each. Let's now take a look at the string type. So inside of the string type, we can see that we allocate 1 byte plus the length of the string. So that means if your string is 7 characters long, it would be 8 bytes in total consumed to send between the client and server. Now the first byte is used to store the length of the string, and then on the other side we read the byte to get the length, and then we use that to read the string. Now because we only use 1 byte to store the length, if we go back to types, remember 1 byte is 8 bits, so it's a U8. Here we can see we do a U1, which is a U8. And that means a string can only have a total of 255 characters, which should be long enough for most people. But if you need more than 255 characters in your strings, you can increase it to a U16 to have 65,535 characters in your string. And to do that, it's very simple. Instead of having 1 byte for the length, we want 2 bytes for the length. Instead of writing to a 1 byte, we want to write 2 bytes. And then when we read the length, we want to read 2 bytes. So now we've just modified our string type to have this many characters instead of 255. But in most cases, just having 1 byte for the length should be long enough for most people. And let's now take a look at the characters type, which works a lot like the strings type, but is a bit more complicated. So the way this works is over here we can see we allocate 1 byte for the length, just like we did for strings, plus the amount of bytes that this character string is going to use. But unlike before, we don't use the length of the string, we calculate the amount based on this bytes value that we calculated over here. And this will dynamically change depending on how many characters you have in your characters array. Now, if you have 64 characters, like we do here, then it's going to use 6 bits per character. If you have 32 characters, then it uses 5 bits per character. 16 characters in your characters array will be 4, 3, 2, and 1 bit. So depending on how many characters you have in your characters array will determine how many bits each character will consume. So because a string consumes 8 bits per character, and the characters, this default array is 64 characters, which is 6 bits, you'll be saving 2 bits per character if you use the characters type over the string type. But the downside of the characters type is you can only use the characters that are listed in this array. So let's go back to server and let's change this from a Boolean 1 to a characters type. And now over here, it's going to say it wants a string. And if we use the characters that are in the array, so for instance, A, B, C are all within the array, we can see A, B, C over here, it should work fine. If we play the game, we can see that the client received these characters and each character should consume 6 bits each. But if I try to send a character that does not exist in this array, so let's try to send a / character, which is not in the array, we can see we get an error. But if you don't want to receive an error and you want the character to be replaced with a default character, we can make a little change. So over here where we try to get the character number, you could say or 0. So if the character is not found, we just pass in the default value of 0. So now if I go back to server and say ABC, ABC, because this character won't be found, it will just default to the value of 0. So if we now play the game again, now we can see that the / was replaced with a space because character 0 is a space. Let's now take a look at the static type. So here in the static type, we can see an array of values, and what happens here is we allocate 1 byte and then we pass the index of the value that we're trying to send. So if we try to send this string to the client, it will send the value of 1. If we try to send this number to the client, then it will send the value of 4 because this is the 4th index in this array. This is index 1, index 2, 3, and 4. So we will send the value 4, and then we will read the number 4 from the buffer when we receive it, and we will get the value from this values array. So you can see that by using a static value, we only consume 1 byte all the time, even though this string uses 1 byte per character if we used a normal string type. So you can see that a static type can greatly reduce the amount of data we send by predefining the values that we want to send. So let's just give this one a try. So if I change this back to static and I go to server, and I can send this value from the server to the client like so, and press play, we can see that this value gets sent, and it only consumed 1 byte to send it. And if I wanted to, I could send this number to the client, press play, and we can see the client received that number and it only consumed 1 byte to send it. But if I try to send a value that is not within this array, for instance, if I try to send the value of 1, 2, which is not here, and press play, we should see that the client receives the value of 0 because it wasn't able to find it. And we can see we default to the value of 0, and this array has no value at the index of 0. Now, another thing we can do is we can use these modules to quickly check how many bytes each type uses. For instance, if I wanted to know how many bytes does a rect type use, we can see it uses 16 bytes. If I want to see how many bytes a region 3 uses, we can see it uses 24 bytes. If If I want to see how much color 3 uses, we can see it uses 3 bytes. And for brick color, we can see it uses 2 bytes. So checking these modules is also a great way of seeing how many bytes each type uses. For instance, over here we can see we have 3 C-frame types. We have the largest C-frame type, which uses 18 bytes. Then we have this one over here that uses 15 bytes. And we have this one over here, which is the smallest C-frame type we have, which uses 12 bytes. And we can see that over here we get the angles, rotation X, Y, and Z, and we can see we use 1 byte for every axis of rotation, and we can see we use 3 bytes for the position of the C-frame. And if we look at the other ones, we can see that this one uses 4 bytes for the position and 1 byte for rotation, and the largest one, which consumes a total of 18 bytes, uses 2 bytes for every rotation axis and 4 bytes for the position. Now, just because we only have these types built into the module, it doesn't mean we have to keep only these types. We can delete types, or we can even add our own types. So let's now add some of our own custom types so we can see how easy it is to add more types. What I'm going to do is I'm going to duplicate the static type, and I'm going to rename this type to error messages. And in this error messages type, I'm going to only have error messages. So I'm going to have error 1, and then I'm going to have my error message 2, and so on. So I'm just going to keep adding all the error messages into this one type. So here we have 4 error messages that we can send to the client. And now I need to go into the types module, and over here where we defined the type, I'm going to say I'm going to use the same name that I used for the module, so error messages, and then I'm going to say the type that we need to send in. Now for static, we use the any type because it could have any type inside of these values, but because error messages are only going to have strings within them, we can just say string here so that it only accepts strings when we fire this error message type. And we can also add it over here as well. This is not mandatory, but it does work for something else, which I'm going to show you later on. So let's add a string over here, like so. Okay, so we've now added our error message type. So what I can do is go back to the server, change this from static to error messages, and now I can send the client any one of my error messages. So error message 3, and this should only consume 1 byte to send to the client. And if we like, we can make a custom version of characters. So let's duplicate characters, and I'm going to rename it to numbers. And I'm going to remove all these characters, and we can replace these ABCs with maybe you might want plus, minus, comma, and maybe divide. And because this only has 16 characters, it's going to be this one over here, which is 1 byte, 2 bytes, 3 bytes, 4 bytes. So this character array is going to consume 4 bytes per character. And we need to make sure we add numbers over here. So numbers, this is also going to be a string, and we want to add it down here as well. And so now we can use our new custom type. So I'm going to change this from error messages to numbers. And this is going to allow us to send numbers as a string to the character, like so. And each character consumes 4 bits. And let's make another type. So this type is going to be a blend between boolean 1 and number u4. So what I'm going to do is, because number u4 is the closest to how we want it to be, I'm going to duplicate number u4, and I'm going to name this number bool. And let's open this type. And what I want to do is we're writing two values to the buffer inside of 8 bits. What I want to do is in the first bit, I want to store a Boolean, and in the last 7 bits, I want to store the number. So starting from an offset of 0, I want to store 1 bit, and then starting from an offset of 1, I want to store 7 bits. And instead of passing an array of numbers, what I'm going to do is pass in a table, and it's going to have a key called bool, which is a Boolean type, and it's going to have a key called num, which is a number type. So instead of using value 1 and value 2, we're going to say value dot bool to store in the Boolean section, but not exactly like this. What I'm going to do is if we look at bool 1 and move that to the side, here we can see we do a if check. If it's true, then we pass in 1. If else, pass in 0. So if we just copy and paste this over and replace value with value bool, now we're storing the Boolean in the first bit, and then we want to store the number in the last 7 bits. So over here, I'm going to change this to num, like so. Now we need to make sure we read it correctly. So we first store in the Boolean, so we have to read the Boolean first because it's read in the same order that we write it. So Boolean is from 0 and it only uses 1 byte, and the number starts at an offset of 1 and it uses 1 bit. 1 bit for the Boolean, 7 bits for the number. Okay, so just like we did over here, we need to check it to see if it's equal to 1. So I'm going to say equals 1. And for this one, I don't think we need to change anything. That should be fine. Just we're going to change the table, how we return it. We're going to return it the same way we receive it. So bool is equal to value 1 and num is equal to value 2. Okay, I think that should be fine. So let's now add this to our types script module. So let's copy the name, number bool. Now this type is somewhat more complex. It's a table that contains a key called bool, which is a Boolean, and a key called num, which is a number. And over here, we just have to say is equal to a table, like so. Okay, so if we now go back to our server, we change this to number bool, and now we should see we get an error if we mouse over, and we can see it's looking for this table here. So let's change it to a table. Let's set bool to be equal to true and num to be equal to 2. And if we now play the game, we can see we set the bool of true and a number of 2. And because we used 7 bits for the number section to work out the max value, if we open the calculator, what we can do is say 2 to the power of 7, because there's 7 bits, equals 128. We just subtract 1, 127. So that means we should be able to send 127 and it should work fine. But if we send 128, it should loop back round to 0. See, it looped back round to 0. So here we've created a custom type that uses 1 bit for the Boolean and 7 bits for a number. Okay, so now that we know how to create custom types, let's go back and work out what this array here is used for. So if I create a packet that sends let's just send a number U8. And so now over here, it's expecting me to send a number. But let's say I make a mistake and send a string. Okay, Now, if you're using strict, it's going to tell you that you've made a mistake. But if you're not using strict, so let's disable strict, it's not going to tell you that you've made a mistake. So you won't know that you've sent the incorrect type. So if we now play the game, we can see that we get an error message, but the error message is not very helpful and doesn't really tell us where we're making the mistake. So what I've done is, so that we can get better error messages, I've included some functions inside of the packet module that can check the types before we try to build the buffer. So if we go open packet, and let's just close these for now, and if we scroll down, we should see that there's some if checks that have been commented out, because by default these checks have been disabled because most people are going to rely on the strict to make sure they're not making mistakes. But if you don't want to rely on strict and you want the module to check dynamically while in game, what you can do is there's going to be 4 of these comments. We can just uncomment them. 1, 2, 3. And if we scroll down, you should see another 2 over here. And now we've enabled dynamic type checking. And so now our module is going to check this value to make sure it matches the one that we defined in our packets module. So let's now play the game, and we can see that we get a much nicer error message, and it says parameters did not match packet my test packet. And it also tells us that it was on server on line 7. So we go to server, line 7, we can see it didn't match. So it tells us where the error is, so we can easily find it. So if we now change this back to a number and play the game again, the checks should pass and it should work correctly. So that is what this second array inside of the types module is used for. When we loop through these values, we use type of to make sure it matches the types of that we've defined over here. So for instance, here we see number U8. Number U8 should be a type of number. But if we change this to string and run the game again, we can see we get an error. But if we change it back to a number, then the error should go away. But if you're not using dynamic type checking, so if we disable these checks, so now we've commented these checks out, so they should not run anymore. Now this array is essentially useless, and you could even just delete the entire array like this, and it will still work fine, because this array is only used if you enable dynamic checking. Another very important check that the module does is when a client sends a buffer to the server, it will check the length of the buffer, and if it's above a certain threshold, it will discard the message and pretend it never existed. So if we scroll down close to the bottom, over here you'll see a check, and you can see it says remote event discarded due to player name sending X amount of bytes, and the value is currently set to 16,000 bytes, which is 16 kilobytes. So if the client sends 16 kilobytes of data to the server will reject the buffer and just ignore it and won't do anything. But if they send less than 16 kilobytes, then the server will try to read the buffer. And this is very important, because if we allowed for any size of buffer, then an exploiter could send very large buffers and cause the server to crash. Now, if your game requires you to send large amounts of data from the client to the server, you may want to increase this number. But the downside is, the higher this number goes, the more leeway you're giving to exploiters to affect your server. But if your client sends almost no data to the server, you may even want to reduce this number even further down to give less leeway to exploiters. Let me now show you how we can use Packet with unreliable remote events. Now, the first thing we need to know is that unreliable remote events have a limit of 1,000 bytes. So the way Packet works is when you fire many events, all them events get serialized into one large buffer and get sent over a single packet. Now this is okay for remote events, but this is not really a good case for unreliable events. One, because unreliable events have a limit of 1,000 bytes. And another problem is because they're unreliable, and if we batched 1,000 fires into a single unreliable event, you would lose 100 fires if the event never reached the client. So it's not really a good idea to batch unreliable events, but we can still use Packet to serialize the data and compress the data into different types. So let me show you how we can do that. First thing we're going to need to do is add an unreliable event to our project. Now we can name this anything we like. I'm just going to keep it the default name. And then what I'm going to do is, instead of firing the packet like we normally do, I'm going to fire the unreliable event. So I'm going to say game.replicatedStorage unreliable event fire client. I'm going to pass the player. And then we need to send the data that we want to send to the client. But instead of just sending the data like this, we can use packets to serialize this data. Now let's set up our client side. So we're not going to do this like we did before. What we can do is say game replicated storage on client event connect function, and we're going to receive whatever the server sends us. Let's just print it like we did over here, and let's now delete this like so. So if we now play the game, we will get an error, and that is because unreliable events don't really work that well if the player hasn't entered the server just yet. So we're going to need to add a little task wait here for 1 second, just to give enough time for the client to connect. And now we can see that the value gets sent to the client like normal. But so far we haven't been serializing our data using packets. Let's now change this packet type to have more than just one number, just so that we can see that it works correctly. And let's change this last one to a string as well. Okay, so what we need to do, we can do this after the wait. If I get my test packet, so packets.myTestPacket, and we want to call the serialize function. And this function is going to return a buffer, and it may return an array of instances if we use the instance type. So let's serialize, and it wants to give, we have to give it 2 numbers and a string because we said number, number, string. If this was a number as well, then it would ask for 3 numbers, number, number, number. But because we asked for a string, it wants number, number, string. So let's pass in a number of 1, 2. Because these are U8s, we can only go up to 255. Let's say 64, 23, and finally for the string, let's just send A, B, C. Okay, so this is going to return a buffer, like call buff, and it may return an array of instances as well. So now this buffer and instances we want to pass in the unreliable remote event, like so. So now if we play the game again, we should see that the client receives a buffer and nil because there were no instances being sent. Okay, now what we need to do is on this side, we need to use the deserialize function to extract these values from the buffer. So over here, I'm going to say packets.myTestPacket deserialize, and this is going to take in buffer and instances. So the opposite of what we did over here. So we just pass in these over here, and what does this return? This returns two numbers and a string. So number 1, number 2, and a string. And we could pass this into here, like so. And if we now play the game, we can see that we serialize this data into a buffer. We send the buffer over the unreliable event, and then we deserialize the buffer to get the values back. If we wanted to, we could reduce this down to a single line, like this. So now we should have the same result. In this part of the video, I'm going to be doing some benchmarks, and we're going to be using the Packet Profiler plugin to measure the packets, so we can see the difference between remote events and using Packet. So what I've done is created a remote event, and then on the server side, all I'm doing is having an infinite loop that loops every 0.2 seconds, and then I'm firing using the remote event, and I'm also firing using the packet, my test packet. Here we can see my test packet. In this case, we're not taking in any types, and we're not sending in any values to the client. And on the client side, all we're doing is just connected to these on client events, and we're not even printing the value. We just connected and doing nothing on the client side. So if I now play the game, and here we can see the packets being sent. If I click to pause the packets and open the chart, we should see the packet, which is the green one, and Roblox's remote event. Now we can see that remote events sent 14 bytes, where packet sent 17 bytes. Now the reason why packet sent more bytes than Roblox is because Roblox is not sending no values, where packet sends a buffer. The buffer uses 2 bytes, and then it's sending the packet ID, which uses 1 byte, so a total of 3 bytes. So we can see that above the 14, there's an extra 3 bytes being sent by packet. So in this case, firing a single remote event once with no values inside of them beat packet. But what would happen if we fire the remote event twice? So if I say for index equals 1 to 2, do, and if I move these two fires into the for loop, so now we're firing this remote event twice, and we're firing this packet twice. Okay, so I've now run the game, and we can now inspect the packet using the chart, and what we should see is packet now uses 18 bytes, where Roblox's remote events use 28 bytes. So here we can see the two fires, and we can see a single fire for packet. The reason why packet only has one fire is because both fires were batched into a single call. And we can see now we have 4 bytes, 2 bytes for the buffer, 1 byte for the first call, and 1 byte for the next call, where remote events have a total of 28 bytes. That means each call costs 14 bytes. 14 bytes for the first call, 14 bytes for the second call. Okay, so let's now increase this 2 to 4 and play once again. And let's now open the chart and see what it looks like. So we can see that now Roblox has 4 calls with a total of 56 bytes. Remember, each call costs 14 bytes. And packet has 1 call, and each call uses 1 byte within the buffer. So it's a total of 20 bytes. So we can see that by batching the calls into a single call, we greatly reduce the amount of data we send through the network. And let's just go crazy and send 1,000 events. And this is just going to show how well packet scales as you send more and more events every frame. So let's now play the game. And let's now click and open the chart. And we should see that Roblox sent 14 kilobytes, where Packet only sent 1 kilobyte. And we can see the 1,000 bytes being sent inside of the buffer. Okay, so now that we've seen that Packet is able to greatly optimize by batching, let's move this back down to the value of 1. So now remote events should be ahead of Packets, but let's now start sending values to see how Packet can go ahead of Roblox by the types that we send. So let's send a value, which is a number value of 1, and let's pass this into both remote event and Packet. And let's not forget to add this to our Packets module. So I'm going to say Packet number, and we have many number types, but let's use the very largest number type we have, which is a F16, which is the same as how Roblox should send it. And I think that should be fine. Let's now play the game and see what happens. Let's now click and open the chart. And we should see that Roblox should be slightly ahead. Roblox has used 9 bytes to send the number 1. And we can see that Roblox has a total of 23 bytes, where Packet has a total of 25. Remember that if we open the calculator, we have 2 bytes for the buffer, 1 byte for the Packet ID, and the remaining for the number. So 11 negative 3 is 8. So Packet used 8 bytes to send the number, where Roblox used 9 bytes to send the number. Let's now send this number twice and see what happens. And let's also increase this to 2 numbers and play the game. And we should see that remote event is now 32 bytes and Packet is 33, so we're only 1 byte behind. So we can see that was 9 bytes for each number. And for Packet, there's 2 bytes for the buffer, 1 byte for the Packet ID, and the remaining bytes for the 2 numbers. So if we do 19, negative 3, 1 for the Packet ID, 2 for the buffer, that means both numbers took 16 bytes divided by 2. So we can see that each number consumed 8 bytes. And for Roblox, they consumed 9 bytes. So we can kind of see that by sending 64-bit numbers, we're not really outperforming remote events. But the benefit of Packet is the ability to change the type, where we can't change the type for remote events. We have no choice but to send 9 bytes when we send a number. But for Packet, we have options. So for instance, if we know that our number is only going to be between 0 and 255, I can use a number U8 for these numbers. And now, instead of using 8 bytes per number, we're going to only use 1 byte per each number. So we now play the game. And if we select a Packet, we should see that Roblox continues to use 9 bytes per number, where now we're down to 5 bytes. Remember, 3 bytes are used for the buffer and Packet ID, so each number consumed 1 byte each. Okay, so let's now try to send a C frame and see how that performs compared to remote events. So instead of sending a value of 1, I'm going to create a C frame, and I'm just going to put in some random numbers for the position, and let's also add some rotation. So I'm going to say multiplied. Actually, we could do it like this: C frame dot from orientation 1 to 3 plus vector 3 dot new. And let's also make the position 1, 2, 3. Okay, so we have a C frame that's rotated by 1, 2, 3 and is offset by 1, 2, 3. And let's just send it once instead of twice. And let's also enable strict mode so we can see that we get errors again when we don't have the correct type selected. And let's change this to C-frame. Now there's 3 C-frame types. We have the biggest C-frame and we have these 2 smaller C-frames. Let's start with the biggest C-frame that we provide. And once we update, we should see the error goes away. Now that strict mode is enabled. And if we now play the game, and if we stop and open the chart, have a look what happens. Okay, so we can see that Roblox is sending 34 bytes within its remote event, and Packet sends 35. And we can see it's 1 extra byte for Packet. Now, if you remember, 2 bytes for the buffer, 1 for the packet ID. So if we subtract 3 from 21, 21 negative 3, it means the C frame is using 18 bytes, which is correct. So the C frame consumes 18 bytes on Packet, where the C frame uses 20 bytes for Roblox. So even though C frames only consume 18 bytes with Packet and 20 bytes with remote events, due to the small overhead of packets, it's not able to beat remote events when we just send a single C frame, which is from this largest C frame type. But if we send an array of C frames, so let's change this to an array of C frames and do the same for remote events and change this to an array. And if we now play the game, and let's stop and open the chart. So what we should see is we are now sending 4 C frames, and Roblox is sending each C frame for 20 bytes with a total of 96 bytes, and Packet pulls ahead with only 91 bytes. And the reason why it's 77 bytes, let's bring out the calculator. And so remember that 3 of the bytes are, the first byte 2 is for the buffer and 1 for the packet ID. But now we have 2 extra bytes at the front. And this tells us the length of this array. We can see there's a 4 here because there's 4 C frames. So these 2 bytes here are indicating the length of the array. So there's 2, 3, 4, 5 bytes used by not the C frames. So 77 negative 5 means that all the C frames are using 72 bytes. Because there are 4 C frames divided by 4, that means each C frame is using 8 bytes, which is correct. And if we wanted to beat remote events even more, we could change our C frame type to be an even smaller one. So our smallest one is 24 U8. And if we play the game, now we should see that we should greatly beat remote events. So now we can see Packet uses 67 while remote events use 96. And let's add a bit of batching in the mix to see how they both act together. So let's say we sent an array of C frames 6 times per frame of 4 C frames per array. And if we now play the game, we should see that with the combination of batching and using correct types, we should be able to greatly outperform remote events. So we can see remote events use 576, where Packet only use 323 bytes. So hopefully these benchmarks have shown you the 2 key areas where Packet is able to optimize your network data. The first being batching, and the second being able to select types that consume less bytes. Thank you for watching my video, and if you have any questions or want to report any bugs about Packet, you can join the Discord server or post it in the forum. The links will be in the description of this video.